In today's note, we're going to be looking at the Pythagorean Theorem. And what the Pythagorean Theorem is, it's a formula or an equation that's used to find the side lengths of a right-angled triangle. So if we look at our triangle here, we have some labels for our sides. So we have a leg, another leg, and our hypotenuse. So the two legs are easy to tell because they form our corner or our 90-degree angle. And that's what's key in a right-angled triangle, is that it has a 90-degree angle in it. And then we have our hypotenuse, which is our other side. It is our longest side in our triangle, and it is opposite our 90-degree angle. So what our theorem is we have two different ones. We have a squared plus b squared equals c squared, and we have a squared equals c squared minus b squared. Now these are basically the same theorem, just rearranged. The first one is what we use to find our hypotenuse. If we want to find that missing side length, that hypotenuse, we use the a squared plus b squared equals c squared. And the second one, a squared equals c squared minus b squared, this is what we use to find a leg. So any one of those legs from the diagram up top, if we want to find that length, we use the bottom formula. And what each letter represents, A and B represent our legs. So for example, if we go back up to our image at the top, we can say that's A, that's B. Again, those can be interchanged. This could be B up here, this could be A down there. It doesn't matter. And then C represents the hypotenuse. So the hypotenuse will always stay C. So A and B represent the legs, C represents the hypotenuse. So what's that saying is that if I have, say, a triangle that has a side length of 3 and 4, if I were to look at the side lengths and make a square off of it, so 3 by 3, that means that I would have a triangle that has an area of 9. If I were to do the same thing on the bottom, four by 4, I would end up having an area of 16, which would give me a square that has an area of 25. And if I were to look at this, it would end up being a 5 by 5 square. So that's how you can end up finding your missing sides. And that's basically what the formula is saying. And if we want to take a quick look at the video over here, we can kind of see the relationship. So you could see how those two squares off of the legs relate to the square off the hypotenuse and vice versa. So that's what the theorem is telling us. So let's use that theorem to help us figure out the side lengths for our triangle. So if we look at a right-angled triangle here, I'm trying to find this missing side. If I go back to my diagram, this is my hypotenuse. So I need to use a squared plus b squared equals c squared. So looking back at that previous triangle, this can be my A, this can be my B, and my hypotenuse is always C. So I'm going to replace A and B with those side lengths. So it would be 6 squared plus 8 squared equals C squared. Now remember, any number that's squared, that means times itself. So for example, 6 squared is the same as 6 times 6. So 6 times 6 is 36, plus 8 times 8, or 8 squared, which is 64, will equal C squared. That works out to 100 equals C squared. Now I need to figure out what C is. So we know squaring is a number times itself. If I want to work backwards from that, it's called square root. That symbol is the square root. So basically what that means is finding two numbers that are the same that multiply to whatever our number is. So in this case, I'm looking for one number where I multiply by itself to get to 100 to equal C, and in this case it is 10. And that you can use on your calculator. You'll have to just look for that symbol. In example 2, again, another right angle. I'm looking for my missing side, which is my hypotenuse again. So again, I'm still using A squared plus B squared equals C squared. A and B, I can mix that up if I want and change A and B, it doesn't matter. So 12 squared plus 16 squared equals C squared. So 144 plus 16 times 16. So 256 equals C squared. This works out to 400 equals C squared. Again, I don't want to get C squared, I want to find C. So in order to do that, I need to square root 400, and I get that 20 is equal to C. So that means that hypotenuse in this case is 20. Example 3. And I'm looking for a missing side here, which is now one of my legs. So it's still going to call this A, call this B, this is still C. So now I'm using a different formula. I'm using the A squared equals C squared minus B squared. So A squared is equal to C squared, so 25 squared, minus B squared, or 20 squared. So we have 625 minus 400. A squared is equal to 225. And again, I want to square root to get what A is. So if I square root 225, square root of 225, so I get 15 equals A. So one thing to note is that the final step you do in Pythagorean theorem, regardless if you're solving for the hypotenuse or a leg, is square root. Example 4, determine the height of the triangle. So I'm trying to find the height of the triangle. One key thing to note, these two lines, what they mean is that the sides are equal. So that means if I have a triangle where two sides are equal, it's considered isosceles. So what that means is that this dividing line here, what that does is that splits my triangle in half. So if I'm splitting 34 in half, that means that this side is equal to this side. So 34 divided by 2 is 17. So that means that this side length is 17. And now I'm looking for the height of this triangle. So if I divide this triangle in half, I have a right angle triangle, and I can look for my height using Pythagorean theorem. So it is not the hypotenuse I'm looking for, it is the leg. So I'm going to use a squared equals c squared minus b squared. So a squared is equal to 12 squared minus 17 squared. A squared is equal to 144 minus 17 squared. 17 squared, or 17 times 17, 289. So a squared equals negative 145. And again, the last thing I need to do is square root that number. And if you try to square root this on a calculator, you should get an error. And the reason you're getting an error is because you can't square root a negative number, which is fine, because that, if we look back at our triangle, we should recognize that our hypotenuse is smaller than a leg. What we talked about earlier, that our hypotenuse is the longest side in a triangle. So what this means is that this is not a right angled triangle. So that means that these dimensions, or this triangle does not exist as a right angled triangle. So we can't continue this question. So even though we didn't get an answer for the height, we still were able to work through the question using Pythagorean theorem, and just realizing that it's okay to get an error sometimes given the right measurements, because that's just saying that we don't have a right angled triangle. So if we look at example 5 now, what we're being asked is this a right angled triangle? Well, let's use our Pythagorean theorem, a squared plus b squared equals c squared. Let's plug in our numbers and see if it works. So in a, b, and c, so 5 squared plus 10 squared equals 15 squared. So 25 plus 100 plus 15 squared, or 15 times 15. It's 225. So we get 125 is equal to 225. And what we know, this does not work. Right? Those two numbers are not equal. So because they aren't equal, we can say therefore this is not a right angle triangle. So from this note, we should be able to use Pythagorean theorem to find our missing side lengths, whether it's the hypotenuse or the leg, and to determine if it is a right angle triangle.